So we're going to discuss angles formed by intersecting lines. In order to do this, we should first go over definitions. So exterior angles are any angles that are outside of two lines, so not between them. So here in this picture we have two lines, and then the highlighted part would be all of the exterior angles. And then interior angles are the angles that are between the two lines. So the highlighted part is all of the interior angles. And the transversal is the line that intersects the other two lines. So here in this picture we have lines M, P, and Q, and we have M is transversal to P and Q. And then these definitions all refer to any kind of pair of angles. And with the exception of the last one, the term actually gives you the definition if you're reading it closely. Alternate interior angles have to be on alternate sides of the transversal and in the interior of the lines. So A and B are on opposite sides of the transversal, but they're both interior to the two lines. Alternate exterior, also opposite sides of the transversal, but now they're both exterior angles, so they're both outside of the space between the two lines. Same side interior, so they're on the same side of the transversal and they're both interior. Same side exterior, they're on the same side of the transversal, but they're both exterior. And corresponding angles is the only one that doesn't tell you the word, it doesn't tell you the definition from the term. But it's one angle is interior, one angle is exterior, and they're both on the same side of the transversal. So calling them one interior, one exterior, same side angles would be a mouthful. So we just call them corresponding angles. All right, so let's practice applying these definitions. We have, so in this picture, our transversal, I'm going to highlight the transversal. The transversal here is the line that intersects the other two lines. And a pair of corresponding angles, there are four pairs of corresponding angles, but we only need to list two of them. But they have to be on the same side of the transversal, and one has to be interior and the other has to be exterior. So one pair of corresponding angles could be angle 1 and angle 3. And another pair could be 6 and 8. Again, 6 and 8 are on the same side of the transversal. One is interior, one is exterior. Alternate interior angles. Now there's only two pairs of alternate interior angles because there's only 4 total interior angles. And they would be angle 2 and 7, as well as angle 3 and 6. Same side exterior, they have to be same side of the transversal and both exterior. So 1 and 4. As well as 5 and 8. Alternate exteriors have to be opposite sides of the transversal and both exterior. So 1 and 8. And 5 and 4. And then same side interior have to be same side of the transversal and both interior. So 2 and 3. Along with 6 and 7. So all 5 of these pairs of angles require a total of 3 lines to form. But linear pairs, we know that just requires two lines. So linear pairs are any two angles that are adjacent and lie on the same line. So 1 and 2 are a linear pair. I believe there are a total of 8 linear pairs in this picture. 3 and 7 would also be a linear pair. And vertical angles are, again, we don't need to look at the third line to identify vertical angles. So any of the angles that are across from each other. So 1 and 6, so they're on the same lines, and they're across from each other. 4 and 7 would also be vertical angles. And adjacent angles, which in this picture, the adjacent angles are also linear pairs. So 5 and 6 are adjacent, 6 and 2 are adjacent. So in the next picture, we have, now we are given angles and we have to classify or what kind of pair of angles they are. Now notice in this picture, we have all 3 lines intersect each other. So we kind of have to be careful which lines we're looking at. So in this we have line M is a transversal to N and P. M is transversal to N and P. We also have N is transversal to the other two, so to P and M, or P is transversal to M and N. So the pair of angles we look at, we have to first identify which transversal they both lie on. So if we're looking at angle 1 and angle 5, then here's angle 1, here's angle 5. These are both on line N. So that means line N is our transversal. Now, 1 and 5, they're both interior angles, and they are on opposite sides of line N. So here's line N. They're on alternate sides of it, but they're both between M and P. So these would be alternate interior angles. Okay, so angle 3 and angle 6. Now we're looking at transversal M. And then these are on the same side of transversal N, or transversal M, sorry. Transversal M. These are on the same side. One of them is exterior, one of them is interior. So these are corresponding angles. Angle 1 and angle 4 both lie on transversal P. And they're both exteriors, and they are on opposite sides of line P. These are alternate exterior angles. Exterior. And then angle 2 and 3, again using transversal P. And this time they are on the same side and they're interior. Angle 1 and angle 2. Now notice these are both on line P and on line N. These are adjacent. They're right next to each other. So these are just a linear pair. And for linear pairs, we don't need a transversal. So we'd have not applicable. Four and 3. So again, these use the same 2 lines, so there's no transversal here. And these are vertical angles. So again, the transversal is not relevant here. There isn't one. Angle 1 and angle 6. Now they do use all three lines. So they're both on line N. So that makes N our transversal. They are on the same side of line N, and they're both interior to M and P. So these are same side, interior. And 4 and 6. These are both on line M, right? So our transversal is M. And we have, they're on opposite sides, and they're both exterior. So alternate exterior angles. Okay, so now you can do the intersecting lines and angles practice, and then later we will investigate what happens if the non-transversal lines are parallel.